So I have the question shortest uncommon substring in an array. We have given an array like A, B, A, D, B, A, D and C. So I have to check. Let me just illustrate with an example. If I have CAB here, like CAB, I have to divide it into a constituent substring like C, A, B, or CA, or AB, or AB, CAB itself. So you can check like C comes in any of such remaining other elements as a substring. Like C here, it is already a string, so I can reject it. Like A I can get as a substring from my AD. If I just divide AD, I would be getting a substring as A, so also A I can reject. B I can get it from bad. CA I cannot get it, okay, from AD, from BAD, from as well as from C itself. So CA can be my probable answer. Okay, so that's the main idea. I have to just determine the uncommon substring that is not present anywhere except that element. Okay, so I have AB as well also. So let us just check. I have AD, I have BAD, I have C. I cannot get AB from any of the three elements. So AB also can be my probable answer. Also CAB, I cannot find CAB since it is given that it does not occur as a substring in any other string possible. Okay, so in any other string, so CAB also can be my probable answer. So I have to determine the smallest and yet lexicographically smallest. Okay, so smallest out of the three would be like CA and AB, and out of which lexicographically smallest would be AB, since aspect value of A is lesser than that of CA. So AB would be my answer index for this. And so similarly, I have to keep on and check for my complete of such the array given and determine each of the answer. Okay, let us take for AD, I can have A as well as D as well as AD itself. So A I can get from CAB itself. Like if I just divide CAB, I can get A as a substring, so A I can reject. D I can get it from BAD as a substring, so I can reject. AD I can get it from BAD itself, since I can have AD as a substring from BAD itself. So if there are all crosses, I cannot form any of such substring. I would just return an empty string like it is given. If no such substring exists, return empty string. Okay, so similarly I have to just fill the complete answer. So let us now just discuss the complete algorithm what we would be implementing here. Okay, so here is the complete algorithm. Let's see how we can implement it. Reminder for the problem, it uses the brute force algorithm directly. We just don't have to think so much. We can just apply brute force. Let's just check for each of the string given and dividing them into each substring. Let's see how we can do it. Okay, so here we have a string named as answer, what we would be returning to as our answer, new string n, like it's in the Java code. You can follow C++ same return if you have. So I would iterate to my complete n size, the size of the array given. I would just have a for loop here for that. For answer, I would be having empty array, empty string for now, and I have to fill that further as I just proceed. Okay, and for each of the the array I have this, so I would be having n as 3 as my answer. So for each of such index like ABC, I have to divide it into substrings using the algorithm of sliding windows. So how sliding window would help here? Let's just discuss here. I would be implementing two for loops for that. J equal to 1 and J, it will going to array of I length, like if I just divide for my for loop, for I would go to I equal to 0 till 2 for the case, since it is 0, 1 and 2. So for I equal to 0, what I can say that I have ABC as a string. So ABC has a length of 3. So here as well I can say that my inner for loop, which is opting me from I equal to 0 till it would go to 2, okay, since 0 1 2. So yeah, so that is the basic ideologically behind my second for loop, and we would increment it j plus plus, and my next slide would be k equal to 0 slide k plus j minus I. This is the main part here which you have to just follow. Like I have k equal to 0 slide k, let's just see it slowly. Slide I have k plus j minus 1. Let's suppose I have j equal to 1 at the first iteration. I have j equal to 1, okay, so and k equal to 0 is 0 as well also, so 0 plus 1 and minus 1. So the window would not be opening for the first slide. Like the window I have to spread the window from 0 till 1 till 2 until the complete string is formed. Okay, so I would just expand my window step by step. Like first I would extend it to a first element, and then I would just extend it for the rest of my answer. Okay, so let us just see for the ABC. So for ABC I have j equal to 1 and k equal to 0. So the window is standing at 0 itself. Like the slide was what, k plus j minus 1. So k is my 0 plus j is 1 and minus 1. So slide is 0. So for my third loop I am going from k equal to 0. And slide I am having 0 itself. Also I have slide as 0. Let's check the stopping point. What is that? Slide is less than array length. Okay, so my slide is, while I have to iterate the third for loop, while my while ABC length of 3 is not completed. Okay, so I can say that less than 3, and I would just increment both of my pointers like k and slide. So k plus plus and slide plus plus. You may just have the patience what we are doing here. You may just check it clearly, and you may just getting it what we are doing here. Okay, so I would just build string s. Like I would go k equal to 0, slide equal to 0, both are 0 0. So I would having a window of size 1 itself. Okay, so it would just iterate once and then it would just vanishes off. When my slide would be greater than, like when I would be having k as, the k as not the k, when I would be just incrementing my j, like the next point of j. Okay, when the j is equal to 2, I would have k equal to 0 at my third for loop, and my slide would be like what, k plus j minus 1. So k is 0, j is my 2, minus 1. So I would having a slide of 1 length. Okay, so that would mean like I would just see for A, like A, and then for B, and then for C. Like you can see, I would just create a string S from the substring k comma slide. So my k was 0 comma slide plus 1. Slide I got 1, so I would getting 2. So substring of array means I had ABC. Okay, so I had ABC, and I am creating substring till index 0 to 2 minus 1. Okay, so we will get 0 1 2. We just get the substring just the index minus 1, the last index minus 1. So I would be having AB. I would be having for AB. So string S equal to AB. So I would just check for it. Boolean flag equal to true. I would just check for I equal to 0, I is less than n. I would just check in my complete array, the given array, for the complete given array, whether the string is the part, whether the string is the part of any of the any of the substring possible here. So here we will now discuss about AB. So that way we would just expand our window. Like the first iteration, the window would be like checking for A. When it is for the one length, then it would check for B, then it would check for C, then it would check, as I have told, AB. Then after that AB, it would check for BC, like window BC, like the window of length 2, window of length 2. Here it is window of length 1, here is window of length 1, here is also window of length 1. After that, when the j is equal to 2, which is my last iteration, I think so. Yeah, if my j is equal to not 2, my j is equal to 3, array dot length equal to sign. Okay, so I have ABC. So when it is 3, j is equal to 3, I would be having slide as k plus j minus 1. So it would be 0 plus 3 minus 1. So my slide would be 2, and I would be creating substrings of k comma slide plus 1. So it would be 0 comma 2 plus 1, which is 3. So for 3, I would be having A, B, C, which is 0, 1, 2. So I would be accounting for my complete string. So indirectly using my sliding window concept, I am just checking for the smallest substring first, and then I am checking for my substring of length 2, and then finally I am checking for the complete string. So this way I am able to manage to check whether each of my substring is lying in my given array or not. Okay, so this is algorithm. If the flag becomes false, that means I have not to include the given string as my answer, since it contains in S. Okay, so that way you can see if the flag and array of I equal to this, or it's compared to this is for the lexicographically smallest thing, you can just check it. Okay, if flag is my true, and if the string is empty till now, then just fill it after processing all these things. If the flag remains true till after the four loops, then if still the flag remains true, then yes, I can have such of the smallest string possible after comparing lexicographically smallest as this. So I can just fill it with this, and finally returning our answer. So that would be the sliding window concept, as well as our brute force approach by dividing each of the substring array into its required uncommon parts.